I think I'm live. I could be wrong, but it's too late now. So here's an annoying thing, and I'm just going to jump right into it because, boy, time is running out. We're trying to get this hunk of junk working. If you want to know what it is, just watch the previous episodes. I don't have time to do intros anymore. So this is our matrix counter. It's counting the matrix line that we're currently on the keyboard. Yesterday, well, not yesterday, the day before, this was suddenly not counting correctly. So now, right now, this is being driven by the NES, which you can't see. It's behind my head. And that was our big hurrah for yesterday, is hook it up to the NES, make the NES drive it. But the count here was looking all kinds of crazy. The annoying thing is, I sit down to put everything back together, get a slightly better camera view so that you can see the actual top of this stuff instead of seeing it from the front in an awkward way. But you can see, I've had this running for a while. What I was seeing yesterday was that, like, it was counting fine for a while and then kind of going sideways, and I don't know if I was just losing my mind. I don't have time to go back and review the video, and you can't really see these very well on the video anyway, but I don't know. I've had this running for like 10 minutes and it's been perfectly stable. As you can see, the thing that I'm really looking for is this LED is my, we're currently on matrix column 0 indicator, which should light up anytime these are all 0, and super reliable. So I'm gonna say, F it, assume I was crazy, or maybe when I shifted things around, there was some wiring that was messed up in this giant gangle, and it's all fine and it sorted itself out, and when I solder this together, it's not going to be a problem. Let's just go with that, because it's working right now, and oh boy, I have, let's see, today is Friday the 2nd, so I have today, Saturday, Sunday, Monday, which thank goodness it is a holiday weekend, so I can maybe spend a bunch of time on Monday working on this. We can do like a hyper mega stream deal. And then VCF starts on Friday, so maybe Friday during the day. I am taking that day off of work, and then I have to drive to Chicago, which is like a 4-hour drive for me. But that gives me some time in the morning to do stuff. So, yeah, I didn't actually count the number of days, but it's because I don't want to. I think I'm avoiding it. Anyway, so let's just go for it. This is working. What I'm going to do is go back to, do I even have a screen set up? Yes, I do. Cool. That's the sound of panic in a man's voice. So let's just go into here and do all I really wanted to do in the first place, which is basically, instead of just what we have right now is this line sets the latch high and just leaves it. And then we just keep clocking and clocking and clocking, and it just cycles over and over again. What I want to do is the proper cycle of raise the latch, do 1 clock, then lower the latch, then do 7 more clocks, and that will cycle through all of the keys, or well, all of the rows in the currently selected column. So let's go ahead and move this into the loop. And I really don't know about, so right now I am using just straight up software timing. I'm using a delay loop here, that's why we're loading XFF here and YFF here, and then we're doing a loop on Y and then a loop on X, 2 nested loops to give us 256 times 256 loops of not doing anything. And I did that because of the weird counting. You know what I'm going to do really quick is actually undo that change, and because it would be really convenient for me to have either the X or the Y register at my disposal, let's just get rid of the Y loop for a hot second and bring back waiting for the V blank. And in fact, I still think maybe it was the V-blank stuff screwing me up and maybe doing multiple clocks too fast. I have the logic analyzer here too if things go sideways, which it's all set up, it's on the camera, it's ready to go. But hopefully we won't need that. So I'm going to go back to, let's see, can I go all the way back? To before I did the, yeah, the Y wait loop code. Let's just friggin' see. Try again. See if it feels like maybe it was a circuitry thing, maybe. Because I pushed this around on my desk, and since then it's been working fine, and it wasn't working fine with this exact same software the other day. So, F it. Also, I need to move chat in a second here, because I forgot to move it into its regular location. But anyhow, this should... Okay, so we've reverted the code back to how it was the other day, which is basically waiting for 60 V-blanks. And really, I guess we should probably wait for V-blank to end before doing anything else, because otherwise our timing is weird. But it was printing these X's on time, so... Like, it wasn't printing several X's. Anyway, waits for 60 V-blanks, theoretically, then prints an X, and potentially... Let's see. Yeah, if we've done 60, then it prints an X, and... Oh, right here. Reads from the controller port, which causes a clock to happen. So let's just revert in order to sanity check this dang thing, build it, run it in FCUX, make sure that it actually still works properly, burn it to the chip, make sure everything is still happy, and then maybe the other day was just a very annoying fluke. Let's see, FCE. No, I don't want the configuration file. FCEU. Type it the same way twice and you get two different things. That's totally cool, Windows. Okay, we should get X's. Cool. Good enough for me. Okay, so we should be ready to burn, but let me move that chat over before I do that. Viapu said, I would be surprised if that breadboard setup worked 100% reliably. Me too, and that's what everybody was saying the last time. Which I didn't think they were wrong, but it is what it is, so... If it's working reliably now, I'm not going to look that gift horse in the mouth too much, you know what I mean? Come on. Just please snap to the right place, you bastard window. There we go. Right, so, burning this thing. Back to the thing. Over to the thing. Loading the thing. Making sure we're on the right chip. Yes, we're still on EEPROM. Load file. Basic.bin. Hit that offset. Load it. Make sure check ID is off. Prepared for programming. Turn off the NES. Remove the cartridge. Remove the EEPROM. One thing is, I'm also going to have to get this, like, buttoned up physically when I take it to VCF. Not that it will be buttoned up very well. And a wire can be soldered. Thankfully, it's an easy little one. But yeah, like, I have to get the lid back on this thing and somehow have the cartridge still plugged in, but also held in place correctly, which I am currently doing with the tweezers. I'm gonna burn that bridge when I come to it. Much like last year, when I was up till like 1 in the morning at my booth trying to solve software problems. But that's the fun of it for me. That is the fun. It's the thrill. All right, let's program this bad boy with the old version. Cool. Thank you for just working. Solder this guy back together. Iron it up to temp. Let's use the new sweet overhead camera that can see about a square foot of my desk. But at least it can see it maybe slightly better than the other angle could before. I don't know. You tell me. That seems connected. All right. So, we're programmed. Let's get this sucker back in here. Nice solid crunch. That's what you want to hear. That means it's working. Yeah, I am going to move my face over to where there aren't really things. Nope, that's the wrong thing. Move my face over to where there aren't so much things. Actually, maybe here? Here? I don't know. They all suck. I'm going to go with here. Hello, Santiago. Hello, Lawless. Good to see you guys. Hopefully you're here for a slightly less disappointing episode. But we're about to find out. We are about to find out. Okay, tweezers are in position. Let's see if it proceeds to count somewhat reasonably. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Mind you, this... When I was looking at it the other day, it looked like it was counting okay and then losing its mind. So let's just look at this for a minute. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 0. Though that's actually rather interesting. And points to another potentially screwed up thing. Note that when that's at 1. Actually, no, that's right. Because this will always be showing basically one row behind what this is showing. Because every time this counts, it also latches what was on the keyboard before it changed, basically, like in the split moment before it changed. So, yeah. Santiago says, really quickly, hey, I was thinking, since I've also had to deal with flashing an EEPROM constantly for debugging purposes, what about a code that allows you to flash the memory from a serial port or something? I will really quickly go over this. I don't know if you've watched my past videos. I have mentioned this before on this stream, because we're going to get back to it. That's what this does. This is a cartridge for the Genesis, has some ROM on it and some RAM, and it has a program in the ROM that allows you to write random payload, anything you want, to the RAM in here, and then you can jump to it and execute it. So theoretically faster turnaround. I haven't really had a chance to use it. So okay, I haven't looked at this in a while. Is it still going properly? Is it losing its mind yet? Let me try and cover this up well. Like the light and the camera are perfectly lined up. 1, 2, 3, 4, 5, 6, 7, and 0. Seems stable. I'm gonna say ship it. Let's move on then, because this keyboard needs to get done forthwith. Distracted man doesn't know where any of his stuff is. All right, so really what I want to do here now, like I was saying, is let us just start simplest first and build up. So now that we're not using Y, let's also load Y with 7 here, and load Y with 7 when we reset here as well. Though really that won't happen there. That will happen... Where will that happen? I guess we'll have to have a separate place where that gets reset. So what we want to do here is we wait for a VBlank and keep looping until we've reduced X to, we've reduced X to 0 from 60. Then, and actually I'm going to speed this up a touch, replace that with 30, and replace this with 30. Okay, so keeps looping here until it hits 0. If it hits 0, then we fire off a clock. But I want to also decrease Y and actually, before I decrease Y, let me I wonder if transfer Y to A affects any of the flags, because that would be useful. Because if I can check here if it is, because first I want to check if it's 7. If it's 7, then I want to turn the latch on. Yeah, let me just get rid of this, because that shouldn't be here. It should be inside of the inside of the actual loop. Delete that. Let's just move that, I don't know, somewhere in here. Every time we do this, let's just drop it in here, and let's just drop it in here, and I will put code around it. That will actually make it do the right thing. But for now, let us transfer, let's just do it the slow way. Transfer Y into A, compare with literal 07. If it branch on equal to I'll just need a new label. Thinking forward for some reason, a thing I cannot do. But yeah, we'll do a label here called no latch. Yeah, we'll call it no latch. Whatever. Doesn't matter, as long as it works. So if it was 7, or no, let's do branch if not equal to no latch. So if it wasn't 7, then we'll jump to no latch, which we will write code there in a minute. But otherwise, actually that's where I need this code. This is the code that raises the latch line, so we will put that there. And then we will clear the carry flag and branch if carry is clear to, let's call this latching done. And latching done will be just past no latch. And that will just be the code that carries on with whatever we want to do, irregardless of the latch. Irregardless is not a word, regardless of the latch. And no latch is going to do the opposite of latch. For simplicity's sake, I'm just going to do this every cycle. No real speed reason to do it one way or the other. You know, like, it would be kind of correcter to check to see if Y is 6 and then only lower the latch, instead of repeatedly lowering the already lowered latch on every clock, but it doesn't really make a timing difference, I would not imagine, so who cares? Probably functionally exactly the same. Anyway, I really don't care here, because I'm just trying to get something to work. So, yes, we will load a 0 to lower the latch, and write that to the latch, the controller latch register, which is 4016, as we can see above. And that will just fall through to latching done. And that, we really should subsequently decrease Y. And then if Y is 0, yeah, if branch if equal is branch on 0, and we will, no, let's do, if it's not 0, then we don't need to reset it, but if it did count down to 0, then we need to reset it. So we will jump over the reset part, no row reset, let's call it that. So otherwise we will I have lost myself. Let's just roll with it. Even if I write something wrong, we can debug it in a minute. But anyway, so if it was 0, which means that we didn't do this jump here, then we just load Y back to a literal 7 again. I guess hex to be consistent. And then that's pretty much it for that. Okay, that seems kind of right. So what this will do is, instead of just having the latch constantly high, I'm watching you. It did. It lost its mind. God damn it. You're not looking at this. Hold up. Hold up. Look at this shit. Nonsense. It's nonsense now. How did that happen? Well, we can ignore it. Assuming it runs okay for a while startup. No. No, what the hell, dude? I'm just gonna, yeah. Yup, it's something about that horrible nest of wires, because look, it's fine now. That's hilarious. Okay, that makes me feel better, though. If I jiggle the handle, it works fine. Back to what we were doing before I flipped out. Let me check chat. Lala says that quick flash cartridge would be a great thing. Yeah, it would. I think I think there are carts out there that have just like a USB interface that you can just run code into them on the fly, but I don't think they're incredibly common. But whatever. User named only C says, how much did it take you to dominate this set of assembler? I'm only used to 8086 assembler. I'm not good, but this is 6502 assembler, and it is ludicrously simple. There are 3 registers. There's really only one that matters. The other 2 are used more or less for indexing and other sundry backup purposes. And you can load to them, you can add, you can subtract, you can do branching, you can do some bit operations, and that's basically it. That's it. No extended commands like in 8086. It's real easy. Anyway, so yeah, so this code should be clocking 8 times. That's where I might have a bug. Hopefully it clocks 8 times. No, I'm gonna hedge my bets. I think because of the way that we're doing this reset, or doing this Y incrementing, or decrementing rather, I think that needs to be 8. Because when we hit 0, it goes right back to the original, to the, starting value without doing anything in the interim, so I think we need to actually do 8 there. Okay, so that will, on the first clock, it will make sure that the latch is high before it does the clock. If it's any other clock, it makes sure the latch is low. And when the latch is high, the way this hardware is built, if we get a clock when the latch is high, it will latch in the current row values on the keyboard. So for whatever column is selected, the keys that are on that column that were pressed will be positive, which will actually come in inverted because of the way the NES does things. And then all subsequent clocks after the latch has been lowered will simply shift those values out of the shift register, which is hooked up to the controller input. So hopefully what that would mean is that we should see this update to have some values on it, and then they should shift out, and then it should load the next row of, or the next column of keys, shift them out, load the next column of keys, and eventually repeat. I am going to give this the old test just because. Because it's still counting relatively slowly, so we should see it working. And then I need to actually start trying to read in the clock values, which is, or the individual key values that are getting shifted in, because that's the part that I am honestly worried isn't the right word. Yes, let's bring up the weather. That's what I wanted. But maybe slightly apprehensive. I closed the emulator. Cool. Because I don't know if the very first bit will get read properly. But if it doesn't, then we just have to zhuzh the hardware a little bit. Okay, just make sure that this is still basically doing this. Look more or less right. And you know what I can do is I can look at the debugger, and this will, well, I can't really watch in real time. how do I just pause this? If I just do NES, oh, emulation speed, pause. And is this showing me the actual state of this thing? Let's see, I actually want to... Where is my place where it is? Actually, doing the code that I just wrote. Where is that at? Where is my actual... Okay, here is my PC. Here is my decrement X. Cool, here's my transfer. Whoa, buddy. Let's just resize this window a bit. The scaling is really not doing great things for me. So we move Y into A, we see if it's 7. Yeah, let me break here, E14B, just to make sure this is doing something reasonable. E14B, wait no, that's the end address. E14B, when it's executed, OK, and run, and it is 20 for some reason. Why would that be the case? Where else am I touching Y? Let's try breaking at E15C. E15C. Let's delete this one. E15C. When it is executed. OK, and run. Okay, so this should decrement Y. I have no idea why it wouldn't. Yeah, it decremented it down to 1F. Something's setting it back to 20. Okay, I am... Oh, god damn it, it's the print character code. Always happens. Always friggin' happens. Let's just jam this one in the 0 page and be done with it. Where? Oh, where? Alright, no, you can't push directly from Y, which is annoying. Let us... keep it on the stack? What if we just keep it on the stack? I think that's probably fine. If we just make sure we push it before everything. So instead of loading Y, let's replace this with load 8 into A, and then push it onto the stack. And then here we will pull it off the stack, see if it was 7, blah, 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 do a bunch of stuff. We do lose it, though. So, does pushing it... Oh no, because I want to access it here later, too. Let's check the instruction set really quick and see if pushing upsets any of the flags or if I can use it right there. NES 6502 instruction set. And let us look at PHA, push a command. And it does not set any flags. We can use it right there without upsetting any of the flags that we just set in compare. Perfect. So we'll pull it, we will compare the value, and then push it back, and then I think that's basically just about as good as using a 0 page value. And subsequently, let us pull a here, and then I don't know, transfer Y A into Y, doesn't really matter, DEY, whatever, And we can do this trick again, because the value is still in A, it just happens to be in A and Y after a transfer A into Y. So, push it back onto the stack, and that should, I think, keep our stack balanced. Let's run it in the emulator and make sure my logic is sound here. Okay, now it's not doing anything, which is probably because I didn't hit run. Okay, that is doing things. And now what if I NES emulation speed, pause. Y still has 20 in it, but whatever. Our stack has 8 in it though, which is good. I don't know why this breakpoint isn't breaking anymore. Probably because I just reloaded the whole cartridge. It gets a bit weird when you do that, this emulator. But it should be... well, no, it's actually going to be a different breakpoint, which is probably why it wasn't happening the way I expected. But where is our... transfer AY down here? Yeah. Oh, pfft. Well, there's a problem. I decrease Y, but then I don't put it back in A. Whoops. And I don't think there is just a... I think you can only decrease the X and Y registers. I don't think you can decrease A, which is a bit annoying. So actually I need to transfer Y into A. Sure. And that should still be fine because it will set flags, but if it sets the 0 flag writing this, that's still fine, because the 0 flag would be set if A has become 0, which it would if Y was just decremented and became 0 and then went into A. So I think that's also fine. But I think a lot of stuff. I think a lot of things. Many of them wrong. Okie dokie. Don't pause it. Load it again. Open it up. Okay, it's doing stuff. Cool. Now, let us... where do we want to pause? I guess... here is fine. E15E. Right? E15E. E15E. Okay, and has it broken? It has broken. And this has gone insane, apparently. Has it executed that step? Yeah, no. So this has gone insane. That's fun. Can I reset this whole thing? Well, it is being debugged. Okay. So let's just look at this every time we hit this breakpoint. 8, 7, 6, 5. It's probably because that assumption I made about setting the flags is not, does not hold. Okay, so it's 0, so let's step over. So now that 0 goes into the A register. We transfer that value into the Y register. We decrement it. Oh, that's weird. Actually, this should have happened on the last cycle, right? Yeah. Anyway, and now we push that, so now we have the wrong value on the stack, and I mean our 0 flag is not set, which of course it wouldn't be because it's FF. So let me actually reset this again, and I want to catch it when we have 1 on the stack, not 0, so I can see what happens when it actually gets all the way down to 0. 4, 3, 2, 1. Okay. Step over. It's now in A. Got moved to Y. Got decremented, which the 0 flag was set after that set, and after that step. Then we push it, and yeah, the 0 flag was set. Oh, this is a logic issue on my part, isn't it? I am doing a dumb thing. Lawless says, you can right-click the weather widget and disable open on hover. I do it on every machine I remote in. Yeah, that seems useful. Right, so, I only have a foggy idea in my head, but basically it's that, we're not resetting. Oh, of course we're not. We're not resetting. This is our part where it resets the Y register. And yeah, that never gets pushed back onto the stack. There's your problem. So actually, we can do a push in two places on this one. Let's load A 8 and push A. Oh no, you know what? Duh. We'll always push A right here, whether it was the decremented value that we pulled off the stack and it wasn't 0, so we skipped this step. But if we needed to reset, then we just replace whatever's in A with 08 and we still push it. Yeah, that makes sense. Look at me think. I don't know what exactly that was in reference to, but Cliff Cheney says, dumb things are more entertaining. And you are damn right. That's why I do anything I do. It's like a brain disease I have. I find very little interest in, like, the things that should be, like, rationally, reasonably... Like, I'm a developer, right? I do computer stuff. God, I hate new technology. I'm not even that old. The old guys always hate new technology. I'm not super young. I'm in my early 30s, but I don't know, the structure of it, the BS and politics of it all. I try and do my best, but it all seems so superfluous. This stuff is dumb, but it has no pretext isn't the right word. It has no, like, facade of being important, you know? It's just dumb. It's exactly what it is. And I think that's why I like it more. Okay, we're counting down. We're counting down. 3, 2, 1. 8 again. Okay. That's good. Let's run it on real hardware now. Logic fixed. Load. Load. Offset. Okay. Program. Turn off the NES. The NES is already off. I still don't know what word I was looking for. I feel like it's pretense, but it's not pretense. Even though I would call it pretentious. I don't know. I'm going to stick with the facade of it all. In the programmer. Do the programming. Oh, it's done. Here I am just staring at the screen like, do you have another step to do? No, I don't, because I'm finished. And I told you that. I told you that right on the screen. Okay, cartridge. In, confirmed. Switching cameras. Yay, got it the first time. Crunch! Okay, so. This should, do something. Oh! Yeah. Okay, there's row 0 going across. Cool. Now this, it doesn't surprise me. Like, this should just work. If the hardware is more or less there. Let's hold down some random keys and we'll watch it go. But you can see these are very slowly counting now. But now that's a key pressed there and it just got shifted out. I'm just holding down random keys, but so we should see some lights light up every now and then. But these are cycling the matrix, and then every now and then, yeah, see, there were 2 keys pressed down on that row, and they got shifted in. That seems reasonable. Looks good to me. There we go, there's another one. And we should always see whenever we hit row 0, regardless of what keys I'm holding down. Yeah, that is row 0. Wait, no. That wasn't on. I just can't see. Whenever that comes on, that's row 0. And that's the main thing I care about. But now, I guess let's write some code to write a character on the screen. Oh, is the counting gone wonky again? Let's see. Should be 1 in just a second here. No. Okay, the counting still looks reasonable. Anyway, so that's good. Let's add some code now to make sure I am clocking in the right things. And what I mean by that is I'm just going to... Right now we're printing X's. I'm just going to update it so that instead of printing X's every time, we'll print 1 character if we just clocked in a 0. That's what Visual Studio Code looks like. And if it was not a 0, then we will print a different character. And it's going to be... prepare for it to be backwards, because the inputs to the controller get inverted before they get loaded, which is interesting. I think it's because, you know, when you press a button on an NES, it's actually grounding the input, and so that would bring it to 0. So just to check real quick to see if it's on, you would want to see a 1 when the button is pressed. I have to assume, but that's what they do, so be prepared for that. But anywho, so regardless of whether we had to reset the row or not, basically here, this is the part where we're doing the clock, loading the current bit that's on bit 0 of our shift register, or bit 7 actually, and we're not doing anything with it right now. So let us first AND it with a literal 01. Again, I don't really think that's necessary, but just in case there's other garbage, I think all the other values there are always going to be 0, but just in case there's other garbage, it is the 0th bit in this register that is the last clocked in controller value that we just clocked in on line 208 here by reading that register. So let us, if we did that and it ended up being a 0, then we can branch to clocked in 0, right? Yes? Yes. No. Branch if it was 0 to clocked in 0, otherwise here, let's just, I guess if we have a 1, let's print an X and, wait, no, I was going to say an underscore, but I can't remember if our underscore character is any good, so actually let's do a 1, and then we will clear carry, branch carry clear to, let's call it, I don't know, character print done. Hopefully that doesn't collide with anything. So we print the 1, then we jump over this code, which is it was 0, not 1. And so here is our label, clocked in 0, and here we'll just load a 0, clear carry, or no, we don't need to jump here, and we will make a thing here called character print done, a label. So what's going on here is we load the value, we clear everything except for the lowest bit. If it was 0, which is what BEQ does, we jump to this code, load an A. We should probably print it. That would be a good idea. Okay, so we do the print here. Yes, so if it was 0, we load a 0 character into the register, and then we call print character. Otherwise, if we ANDed it and it was not 0, then we don't take this branch, we load in 1, then we do an unconditional branch over the part where it loaded in 0 and print the character. So there is the theory. The last thing I think I want to do is when we have to reset... yes. If we have to reset our counting, let us print a new line, which will print a spurious new line at the beginning because this happens at the very top of the loop, but that's totally fine. So let's load a... it's gonna be... wow, I'm losing my mind. I'm always losing my mind. A new line, and what was the name of that subroutine? It was print character. PRNTCHR. JSR PRNTCHR. And then also print a... what did I call 0D? I was probably wrong. Character return and or carriage return and a new line. And PRNTCHR. And so that means that every time that we start reading a new matrix, we will also print a new line. And this should be fine because I think all of our registers are garbage here. We reset the value of A here anyway. I think it's fine. We are using X here, but by the time we get here, we've already... the only thing that we're using X is for this countdown up here. So I think that is fine. I think. Let's build it and find out. Furniture is undefined. Cool. Line 208. Furniture. Come on, assembler. Also, I'm rushing because I have a thing at 7 o'clock, and yeah, much going on, much going on. But we're just gonna get as far as we can. Did I close FCUX again? Come on, man. File, open, just to do that sanity check to make sure it doesn't blow up. And yeah, this should just constantly keep printing zeros or whatever. Forever. Interestingly, it prints, let's see, the first one it printed 7. That's fun. And then every subsequent one prints 8. That's interesting. Not gonna worry about that right now. That will probably need a fix, but... shh. Let me open the debugger really quick. I don't think this live updates. Let me delete this breakpoint. Yeah, not really. I was hoping maybe I could see the stack updating, but no, you can't really see that. Oh well. Like I said, not gonna worry about that right now. Just gonna burn it and move on, and see what values we get out of the actual hardware. And if the I am the 0 row bit just shows up in the right place every time, then I am fine with that. I am happy with that. The real question is going to be, does the very first bit in the row for any given column get clocked in properly on the first clock? That's the only thing I'm worried about. So, with bated breath, let's do this again. Also, if anybody can hear my baby child moaning upstairs, I have no idea if you can... I can hear it very clearly, but this mic is also quite directional. He's not dying. My wife is taking care of him. Everything is fine. I'm rushing. I am rushing my booty off. Let's get the chip into the thing before we try programming it, huh? And prepare yourself for another nice, meaty crunch. Wait, let's do a little ASMR here. And now we're removing the chip. The edifice of it all. That was the term I was looking for. Thank you, my brain from the past. edifice. Okay, programming. Good. Alright, are you ready for the crunch? Here comes the crunch. Oh, that wasn't so bad. Well, it says there will be a day when a pin will just fall off. I have been saying that since the first day, as I'm waiting for this thing to fail. Of course, I've given it, you know, longer legs to stand on, or I'm sure I'm mixing my metaphors there. I always mix my metaphors. By accidentally tossing the whole cartridge on the ground and then stomping on it with my foot and then having to basically rebuild the whole socket adapter thing, like 2 weeks ago. So, yeah. Honestly, I'm amazed the EEPROM hasn't had a pin fall off from fatigue yet, but whatever. Okay, so here's what I'm gonna do. Let me mess around with my OBS for just a minute to get... where's a good place to put this? So this is the NES screen, I believe. Maybe let me just scoot some things really quick, which will probably screw up that hardware again. And there are flies down here, and they are pissing me off. Yeah, because I want you to be able to see the keyboard so that you can see what keys I'm pressing down. But I also want you to see the NES screen, and I also want you to see the LEDs counting. So, good enough. Good enough. Let's make sure this actually turns on and shows up. No, not really. Probably because my video capture thing has gone AWOL. Or maybe because this isn't my video capture thing. Let me see. What is that called? It's called RCA. Nope, that's the right one. Let me just turn it off and turn it back on, because sometimes it just don't work properly. And needs a little kick in the pants. There we go. Okay, so that's something. Now we've got all ones. Oh. Interesting. So I don't know if you saw that bit go across, and then we got a 0 right there. I think that was our, I mean, that has to have been our row 0 indicator. But it really should have shown up as the last bit in the first row. But let's see if it's consistent. We should get 7 rows and then another 0 coming across. But the matrix column indicator, yeah, I mean, at least it's semi-consistent, but I think that first bit on every line is the wrong bit. I think it's the last bit from the previous line. But whatever, this still gives me an ability to debug. Let's look at the my fat face. Let's look at the keyboard matrix again, and let's look at any of the keys that are these on the 0 row. I have lost that page. Let's see, TI-99 4A keyboard matrix. So it looks like any of these. So let's look, I don't know, doesn't really matter. I keep going for 1. Let's go for 1. I'm going to hold down the 1 key, and hopefully we should see it show up, and then we can kind of look at what got printed out to make sure everything is working more or less right, and finally zhuzh up some code to print out a more reasonable keyboard matrix and speed up the scanning. Anyway, enough gabbing. Okay, so that's row 0. This is on row, or column. I keep saying column when I mean row. This is on column 7, so it's gonna be the very last row that gets printed out. So that's fun. Also, you will see at the very bottom here, we're not clearing the very bottom row as it wraps around while we're doing scrolling, which I'm aware of. It doesn't show up on my monitor, so I'm not worried about it. Okay, so we got a 0 there. Is that in the right place? I'm gonna let it cycle a few more times and then look at what we've got here. I'm gonna have to like take a screenshot or something. Doodly doodly do. Doodly doodly. Doodly doodly do. I wonder if I could have made this go any slower. So it's consistently in the right spot, and it is reading something. So that's good. I guess. Let me also, let's do same column, second row. So the 2 button is also on row 7. Column 7. It is column 7, row 1. Let me be, well, there it was. I was going to say, let me be consistent with my 0 indexing or 1 indexing. Oh, that is also interesting. What on earth? You see there's a whole row of 1s there before we get that. Oh, right, because that's the... What? Nope, I'm confusing myself. I think this is all working properly, but, okay, let's do this. Let's just hold down /. We'll do a final test. Really, all I want to see is how far apart the 0 indicator and the column 0 indicator and the actual first bit of that row is. And I think I see it right in, I think this row. You see it. There's a 0 there in the 3rd position. I think that's the one. And I think that looks fine. And the fact that that's picking up anything on column 0 is good. Because that's the only thing that I'm concerned about, is that first thing where it does the latch and the first clock and everything all at the same time. And I'm not sure when the NES is actually reading, is actually sampling the data line. Wasn't sure if that was going to work. But it does appear to be reading things from column 0 just fine. So that is nice. Yeah, so let me screenshot this real quick. There we go. And bring you back over to my desktop. And open Paint, the tool of all discerning graphic artists. And look at my beautiful visage right there. And let's just grab this and blow it up, and I will double check some stuff, because I can't count while I'm also looking at the screen. And let me blow this up just a touch. That worked. Just a touch. Sure. That is slightly more readable for me. I don't know if that does anything for you. So I know this guy here. Here, let's use the pencil. Let's annotate some stuff. I know this guy here, from watching it, is my, this is my 0 column indicator bit, which appears like 1 too late. This is the 0th bit indicating that the / button is down for that column. So, I don't know. I'm going to mark that in green, and then I'm just going to count. And, woo! Touch points. They're great. So, this is 0, 1, 2, 3, 4, 5, 6. Which is correct. That's correct. Yeah. Because I'm overthinking this. Yeah. My code is wrong. My code is way wrong. Why didn't you guys point this out to me? We don't have... Let's just look at that keyboard matrix again really quick. We don't have 8 friggin' rows. We have 6 rows, plus an extra virtual row that is this indicator dude here. That's why this is all screwy. Now that very first line is screwy because it is. Don't worry about it. But yeah, so actually I should be able to clean this up a touch real fast. because it shouldn't be counting to 8, it should just be counting to 6. That's why. And I don't know, let's do this again, but let's also not make this wait. I'm literally going to just make it go way faster, and I don't know. Is 10 times faster too fast? Will that be readable? Let's go... I don't know. Let's just go 3 times faster. And we will increase from there as we make changes, if that is too fast or not fast enough. Let me change that here as well. Okay, build it. And I trust my changes. I'm just gonna trust them like a maniac. And yeah, are you ready for the crunch again? I made my OBS window too big, so now I can't see chat. And nobody said anything, which is fine. Just fine. But I would like to know if you are ready for that crunch. Doodly-doo. Ding-dong, doodly-doo. Here we go, here we go. Just for you guys. Mainly just for Lawless. Beautiful. Music to the ears. Give it the old program. You know, this would be way easier if we had some kind of like way of serially loading data onto an onboard RAM. I don't know why nobody's had that idea before. Hey, Wereworm! I think you're coming in right at the tail end for me here because I have to take off at 7, but it is good to see you, my dude. Okay. I don't know how much progress you've caught up to this point, but we seem to be successfully reading stuff in a way that goes beyond my wildest dreams, because I figured I would need to adjust the hardware slightly. But no! It seems good. Okay, get this back in. Let's see if I can give you a better crunch this time. Oh, Bram Groot Newland says, what's going on here? Oh, Bram. Oh, Bram. To explain in words what's going on here. That was a pretty good crunch. Just there's nothing in the English language that could be used to describe the horrible crimes against hardware and software that are occurring here. I'm trying to make an NES read a keyboard. That's what it boils down to. We're transforming an NES slowly into an 8-bit home basic microcomputer, hopefully with a floppy disk. We'll see about that. I already have thoughts in my head that I will mention in my outro here in just a minute. But I think we'll cut it off here. This code should print the status of the keyboard matrix. Fine. I mean, it's just a faster version of what we just did, and doing a new line every 6. 6? Fuck. Damn it. There are 6 lines and a 7th virtual line. Damn it, it needs to count to 7. Did I count to 7? I don't think I counted to 7. No, I counted to 6. Whoops. I'm glad I caught myself. Anyway, same code, but faster. And with better line breaks in the right position. Anyway, it works, so this is just for show, really. I keep going to my stupid face. Yeah. Okay. Sorry. This should be 7. I think. This should also be 7. Maybe. Okay. Alright. Faster, and now doing line breaks after 7 bits. We still had... Wait, let me look back at the screenshot, because we should fix up some other things. because this should be showing up as the last thing on this line. Would that be fixed by what I'm doing? Let's see. So what I'm doing is having the line break 1 earlier, which would shift all these over to the left by 1, which is not quite right. We've still basically got an extra bit at the start here for some reason. Let us do something. I guess really I have to figure out why it does the extra thing at the start. Let's run it through the debugger, because that should be pretty easy to figure out, that bug. And then it will be the cleanest. And of course I closed FCUX again, because that's what I do. Okay, let's load it up and like immediately pause it and set a breakpoint. Fuck, too late. Too late. Well, that's fine. Let's pause it, open up the debugger, reset it, set a breakpoint at, I don't know, I guess wherever it prints the first new line? Because I think it's basically printing the new line just too early. Yeah, but my brain is kind of too mushy right now to, like, logically think it through. So, let's just look for where we decrease Y and, I don't know, do some stuff. Where is the blah? I don't know. We want the one where it has a decrease Y. Transfer AY, decrease Y. Yeah. This looks right. Then we push it. Yeah, this is around where we want to be. So the new line, yeah, the new line is right here, and it should probably be somewhere else. So it prints the new line when we wrap, when we get down to 0. Really, I think this is just an issue of our decrementing and our checking not really happening in the right order. But again, mush brain, end of a workday, can't really figure it out. So, blah, blah, blah. What if I just... No, that's stupid. But what if? What if the quick fix, that is not the correct fix, mind you, but the quick fix is, we initialize the counter for cycling through our rows to 6. Or maybe to 8? And... yeah, I think that might work as a quick fix, actually. Because it's still doing the same number of clocks on the hardware regardless, but this will force us to do one extra at the very beginning, which is not the correct fix, but I do think it's a fix that will work. Let's find out. The correct fix is to actually write the new line at the right time, but I ain't got time for that. Okay, good. I have nothing set for breakpoints, because I don't want those. Unpause. Yeah. Now, like I said, I think that will actually fix things in that we're sending the same number of clocks, so things should actually be lining up properly, even though that's not the right way to fix it. But whatever. I think that'll work fine. So, let's burn it again. And I promise this will be the last time, and then I'm done for the day. I have things to do. It is 6:49, which is 10 minutes to a thing that I have scheduled but not made any plans for with another person. So that will be fun. Right, so back and load and... See, this is where it gets fun because I'm interacting with hardware and software at the same time. Like, the first part of this was software only. Yeah, it was software only. And then while we were building the keyboard crap a minute ago, it was hardware only. But now we have that lovely, lovely interplay of hardware and software all at the same time. I think I already programmed this. I don't know. I'm just going to do it again. And put it back in the thingy. Anyway, that is so very satisfying. There it is. It's on the same button every time, you dingus. You dingus brain. I just want to pause because I saw it out of the corner of my eye. I'll read. There are a couple other comments too, but Bram said, after he asked what was going on, says, "Oh, that sounds pretty fun." Good. I'm glad that you popped in and you weren't immediately put off by the goofiness. This is very non-serious. This isn't like we're trying to build some cool product for the NES. This is futzing around for the fun of it. If you look at my YouTube channel URL, it's Track Zero Futzin', because we're just futzing. Worm says, as we all know, the 3 hardest problems with coding: naming things and off by 1 errors. Of which, every time I hit this assembly, that is the problems that I have. Bram says, say hi to that person you're meeting at 7 p.m. That'll make a nice topic to talk about. He is aware of this project. He's not really of the scene. I'm trying to get him into the scene is actually kind of what the whole deal is about, but yeah. It's a tutoring type deal. I'm very much looking forward to it. Tutoring a friend. So yeah, this would be the perfect thing to talk about, I guess is what I'm getting at. All right, into the NES you go. I'm feeling in that brain space where I'm sure I am missing obvious things, like the other day when I did not program the chip, shoved it back in the NES, and then was like, why hasn't it changed? I feel like I'm in the headspace where I can make that exact same mistake again. But it's in now. It's in now. Let's just run it and... Is this right? Is this right-ish? The fact that I'm still getting a 0 at the beginning of the line is gross. So that's still the problem. That didn't solve my off by 1 issue. It's definitely... So you see that 0 at the very beginning? That is a spurious 0, and it's screwing up everything. So I will have to fix that up. But I'm okay with this. This is a big improvement over yesterday. It shows that, it was just hardware problems, because as far as I can tell, this is still counting reasonably right. And then, yeah, if I hold down / we should see a... Yeah. So we're off by 1. I have managed to shift everything over by 1, but we're still off by 1. Proof of concept. This part isn't moving as fast as I wanted it to, but there you go. It is detecting the key presses. And just for fun, let's see. What are all the keys on that row? So it is /, greater than, less than, M, N, and plus minus. So that should light up the entire, all of the rows on this column. Let's see if it happens. If it does, then I am reasonably convinced that the hardware is fine. And that the NES can read from this hardware just fine. Which is potentially nice. Oh no, the counting went all fucky again. No, it didn't. So why am I just seeing all 1s now? What has happened to you? Right as I was saying, the hardware seems reasonably okay. Is it something to do with me holding down all those keys? No, it has just kind of stopped working. Okay. Let's just try, I don't know, / and greater than. Oh. That's unfortunate. It sees / but not greater than. Is it a wiring error on my part? Is it... Okay. Weird. So it sees / and less than. Huh. Fascinating. But when I do greater than, it just doesn't even see it at all. Could just be because that key is still broke. This is a really fudged up keyboard. I wonder if I might be pulling cracked ground with that one. That key might be I might have keys that are screwed up and pulling things to ground. That would be weird. I don't know. Let's hold down MNN/. Regardless, I'm playing with it right now, but this is good enough. Yeah, it's doing funky things here. Sorry. This is good enough that I can write my actual full key matrix scanning code based off of this and then figure out what's wrong. It's clearly something wrong with the actual keyboard. It's not wrong with my hardware. If you watch as it cycles through, and then I will stop because this is very slow and kind of like watching paint dry. See, so like it's showing exactly the right stuff over here. It's being read exactly right. It's just my matrix is screwy for some reason, which is easily fixable once I have this software written. So next time we will do that. I'm just glad. This is basically where I wanted to get yesterday, or the last time I streamed, and then didn't get there, so this is fine. So, Groot said, or Bram Groot Newland said, "Is this eventually turning into a game?" And Wereworm, who for the record, Bram is here like at least a solid 50% of the time, says, "Well, depends. Define game. You could write a game in BASIC and then technically it'd be true. Just for you, Bram. The goal is it's not to be a game. It's so obviously I've written these character output routines, which is how I'm printing characters on the screen, and now we're working on building keyboard input routines for this keyboard situation, and then I'm taking this to a computer convention next weekend with whatever I have done. God knows. And here's a cat again, as usual. And then the ultimate goal is to port Microsoft Basic for the 6502 to this thing, and then use the keyboard routines and the character routines that we've written to make that work, basically. I don't know what I'm actually going to have at the convention, which is VCF Midwest. If you're in the Chicago area, check it out, because it's going to be cool. But we'll at least basically have an NES that you can type things into and see characters show up on the screen. So, yeah, not a game. Really the opposite of a game. We're taking a game console and making it into a boring home computer. And that's that. So anyway, I was saying stuff about VCF. I was saying I had some thoughts that I wanted to share as far as what we're going to do with this at VCF, and they have totally... Oh, no, as far as timing. So, I only have a few days left here, and I only have 3 minutes left in the stream before my time is sadly up. But, yeah, so this weekend I'm going to cram hard. I don't think I have anything planned for the weekend otherwise, so I'm going to cram. And then Monday I'm going to try and cram too, because that's an off day. And yeah, what I'm gonna try and do is maybe this weekend, maybe hopefully tomorrow, we can do a super cram day and just finish this keyboard stuff, kind of like I did with the text, because the text we did like a 4-hour stream or something, knocking it out when we were pretty close. Probably gonna try and do the same thing with the keyboard maybe tomorrow, and then from there, I'm going to try and attach a floppy disk controller to this thing, which is probably a really bad idea, because not only do I have to connect it, I have to write software for it, which is the fiddliest bit, especially when I have to keep putting it onto the NES, because it's hardware that an NES has never seen before, and therefore emulators do not have, because why would they? Because it's insane. But yeah, we're going to try. And then I'm thinking, I don't know, like this is so ambitious for the timeline that I have. It's not gonna happen, but I'm still thinking about it. I think I'll just try and implement really simple reading and writing sectors on the floppy, and then maybe try and make like a guest book thing, so we can just store you can store 512 bytes of any kind of message onto the floppy, and then make some kind of way of like, again, it has to be so dead simple because there is no time. Maybe just like have a prompt that says, these many messages have been written, which one would you like to see, and then you just put in a number and it will read that sector, load it, and then just print whatever's in that sector. No file system on the drive or anything, just raw data. And then yeah, you can then also write a message into whatever next sector is free. It'll definitely get spammed, but it's going to be, I mean, this is at a physical convention, so people will have to walk up and type on the keyboard to actually do this. So I'm not too worried, because, you know, a 3.5-inch floppy disk has, I don't know, 1.44 million divided by 512 sectors on it. That's a few. Yeah, so time's up. Wereworm has put an alarm clock in the feed to let me know, so yeah, Bram says he's in Norway, so my live streams would have to do. All right, see you guys. That's my thoughts. Tomorrow I will probably be around a lot, hopefully. And the cat says goodbye with his asshole. All right, guys. See ya. Love ya. Bye.